I hope.
I'm going to talk about 10 minutes. So.
Yeah, it's a joke, right? He's got 5. No joke.
We've got 5 minutes. 5 minutes. See, 5 minutes. All right, I'm Chris Lonvik. Thank you all for coming. Director of Research and Advanced Development with Cisco Systems. And since I do have a very short time, I'm going to be running through a lot of things because Cisco really is a green company. We do a lot of things that first help us by ourselves with our business, and second, we enable you to become more green within your data centers. So, first thing I want to start off with is the Greenpeace report. This is, we could use this as the summary, but we're pretty proud of this. Greenpeace does this, they go through and put the people who should be green, who should be making green equipment together. Last year and the year before, I think we were #1 on their rating list. We fell a little bit. Google got ahead of us. Not a bad thing. We're, I think, just all trying to get a lot of more awareness of what's going on here. And the way that they do this, they break it into 3 different categories, as you can see up here. We do have a lot of green solutions. We are a green company ourselves, and we do have some political advocacy in the green arena, trying to get legislation made, trying to bring up the awareness. So one thing that just along the lines of we are a green company, we are trying to get into the smart grid by helping them become an IP-based, or put IP-based technology into the grid so that they can sustain that better, meet the world's future energy requirements everywhere except here where energy is pretty much free. We do that a lot throughout the United States, and we're doing that quite a bit throughout Europe as well. We do have a protocol. It's called EnergyWise. This is something we're pretty proud of. It is enabled in a lot of Cisco switches. It will take, let's see, if you configure it right with the end devices being aware of this protocol, and we've got it on IP telephones, we've got it on a lot of other end devices that you can plug into the switch. The switch aggregates and correlates all of the information coming from those devices. Each of them would say, you know, I'm using this many watts of power at this point, and you can start sending commands down to the thing. We've opened up this API. We have an SDK for it. We can go through and you can aggregate these things. You can group them together so that if your power company says you all need to shed load, you can go through and actually, with a few simple commands, go out and say, okay, all the IP phones, you need to dim your screen by 10%. The HVACs, you need to do these things. Raise the set point temperatures, various things like that. So there are some calculators out there that say that if you use this and you have this many devices that you could be aware of, you could save this amount of money throughout your whole enterprise by using Cisco's EnergyWise protocol and everything. And we don't do this by ourselves. This is the list of the partners that we're working with. Notably out here, Julex has written an interface so that it's not the real stupid Cisco command line interface. You get a real nice GUI with the thing. Schneider's out there putting their HVACs into it. Delta Controls, Johnson Controls, sorry, Delta and Johnson Controls. A lot of other companies are starting to use Cisco's EnergyWise protocol to not only connect things via IP, but also allow central management to let your IT department manage your energy awareness and consumption, everything like that. We're also into standards for energy efficiency. We participated quite a bit in the 802.3az, Energy Efficient Ethernet. Right now we've got mostly the people that have been working on the EnergyWise protocol. They're over in the IETF working on the MIBs for the energy management, the EMAN working group. Okay, who didn't expect Cisco to have a slide on telepresence at this thing? Raise your hand because I want to know, you know, who's been living under a rock there. Yeah, thanks, John. Okay, so yes, we do telepresence. If you use this, it's not going to replace a gathering like this, but face-to-face communications, you don't need to travel all the time for those. Green facilities and data centers, this is something that's new with our advanced services organization. They will come in and they will actually, see if we can get this. If you're interested in that, see me, see the guys at the booth outside, whatever. They will come in and actually spend some time going through your data center. And I know the guys that have been doing this thing, they will look at the airflow within your data center. They'll look at the trying to use energy efficient Ethernet, trying to use switches, and help you plan out, you know, if this rack is not being utilized fully, why don't you shut it down for a few hours, transfer the load over to some other racks and things like that. So we're really trying to get a new practice going with what we can do within your data center. And they've got several components to this. Like I said, it's brand new, but it's something that's out there that we can get you more information on if you're interested. So, sticking within my time limit here, Cisco really is a green company. We've got a lot of products and services that can enable you to make yourselves green as well. I think if there's any questions, I could take them. Otherwise, I'm going to stick to John's 5-minute time limit here. Thank you.
I love you. I love you. I love you. Can I ask the next speaker? Thanks very much for that, Chris. Can I ask the next speaker? And Yves Pop, somebody who's been around in our community for a long time, knows a lot about what we're doing. Yves from Tata, a well-known small company that does just about everything. But they do it green, huh?
Green, green,
green. Green, green. Okay, so, Yves.
Thank you very much. So we're gray, and we're on our way to become green. And in fact, if one looks at the Tata group, I think there's a reason they're interested in green, because some of the major components of the groups are Tata Power, which of course have to consume things to make power. They generate or have a capacity of about 5,300 megawatt down in India. There's Tata Industries. Also, by definition, in the old definition of polluting industry, you have Tata Motors making things like the Nano you're familiar with, or Jaguar and the Land Rover in the UK. Then you have the communications division, which I think is less polluting, but still we consume a lot of energy. And of course, you have things like Tata Tea. If you drink Tetley tea, that's also part of Tata. If you go to the Taj Hotel, that's part of Tata, which is they are in fact equipped with the Cisco telepresence system, which also saves money. So basically, to make a long story short, from a big corporate point of view, there is really a motivation for green. And in that respect, I think the best way to force green is top-down, and Ratan Tata, our chairman, is really committed to green. And to do that, he has created a committee, and he has told every one of his companies, you have concrete objectives to reduce the carbon footprint and become green. And about 300 people in the company on a corporate level have been trained to become the green advocates. So out of that, of course, he has his orders to the troops. And if we look at what he says, you will play a leadership role, you will benchmark, and you will engage actively in the advocacy of climate change. And of course, you have to participate in all organizations. Now, if we look at some examples, Tata Power, they have a commitment to have 25% of their power generated from clean energy, basically 4 variations. You have wind, solar, you have geothermal, and hydro. So in this context, we made an investment in an Australian geothermal startup, which is called Geodynamics, and there's a huge project underway for geothermal plant in Indonesia. Indonesia, as you know, is like Iceland here, rich volcanic activity, so prime ground for geothermal. Tata Industries is investing in a Swiss thin film company, Film-Som. In fact, the idea there is to have photovoltaic cells which are on a kind of a plastic cover. So basically you can bend it in any way, shape or form and place it everywhere. And they are going now in pre-production soon. Tata Motors, they're quite interesting. Chairman is quite involved in everything which is automotive. And in that context, he decided to put money in the air car. At first, everyone was laughing a little bit. The air car was developed by a Frenchman called Guy Negre, who was involved in Formula One, and basically he developed a compressed air engine. And it has been tested in a Tata, modified Tata car in India. In fact, there are video on the subject, and it's there. Again, will it become commercial? We will see soon. Now, in the same order of idea, they also developed in a battery developer, which is called Miljebil Greenland. They're based in Norway, and they have a battery based on lithium-ion superpolymer, which is in fact under license from a Canadian company based in Mississauga, which is called Acervaya or something like that. So there's a Canadian component. Tata Steel in Dysol. That's quite an interesting one in my opinion. There again, their principle is to make kind of a coating of solar cells. And what they did there is they discovered that titania, which is a component which you find in white paint, and ruthenium, if you spray that, it generates electricity a little bit like in photosynthesis. Another one, which is the last one, is Daniel Nocera. I don't know if some of them are familiar with him. He basically developed a system where you make energy from water. He discovered that by putting a modified cobalt in and coated, I don't know what anymore. Anyway, it produces electricity. And so that's all the examples. Now, of course, we're in telecom. Global network consumes energy. Ethernet and internet networks consume energy, much less now thanks to Chris, who improves his equipment. And basically, you have to lead by example. You have to use telepresence. In fact, our data centers are powered with wind turbines, cloud computing. Everyone is talking cloud computing. Then advocacy member of the GREET Global Consortium, and of course, the internal changes. To conclude, the Chennai data center was cited as an example. There's the World Energy Forum in Lille, France, meeting every year, and they're very proud to have gotten a first prize and a best practice paper. And in fact, it is saving a lot of money. So energy and becoming green is a profitable business. Thank you.
You can stay up here if you like. Eve, you can stay. I get a bit lonely up here on my own. Can I now invite the next speaker, Michael Ritter? Thanks, Michael.
Where do you have the...
Do we have a clicker?
No? Anyway. Good afternoon, everybody. So I'm Michael Ritter from Adva Optical Networking. As a vendor of optical transmission systems, we have quite some experience with saving energy. So we supply our equipment into data centers since a long time. And They like systems with low energy consumption, not only because it saves money, much more because the amount of energy you can consume in a data center is simply limited. So there are many data centers out there where there's lots of space available, but the energy which is available to be consumed is already at its limit. So it's quite an interesting topic here, how to reduce the carbon footprint. And I thought, before we discuss what we can do, let's first figure out what's most critical. And from talking to many of our customers and from listening to what the industry says, we all know the most critical part is power consumption. And right after power consumption, there's power consumption. And then it doesn't take long until we get to power consumption again. So power consumption is definitely very, very critical in our industry. But there are also other things there, business travel. So if you install your network, you need to travel there. If you want to talk to your people, you very often travel there. You have meetings, you can do teleconferences, all these things to save money there. To avoid travel for install, troubleshooting, there are lots of things you can do in the meantime where you can really configure and administer the systems from remote. So there are lots of things which are very positive for us to reduce the carbon footprint. And last but not least, lots of carriers, and I think it's the same in the Enron community, they also take care about supply chain emissions. So how you package, is it effective packaging? Can you stage it before that you don't have lots of parcels to be assembled later? So lots of things there you need to consider in order to figure out how to reduce the carbon footprint as much as possible. And there are some studies out there which indicate that the ICT industry can really help to reduce the greenhouse gases by 15% or even more by 2020. So it's a significant amount there. Now, since we're from the optical industry, let's have a look what we can contribute to that, what we are doing there. And there are different categories we need to look at. So let's start with electronics. How can we save energy there in an optical transmission system? Definitely there are lots of ways to control energy consumption in a smart way. So we can switch off functionality you don't use at the moment. So there are things like forward error correction you don't need on short links. There are things like encryption in the meantime you can switch on and off. So there are lots of different functionalities, monitoring functionalities and so on, you don't need all the time. So why not switch them off and reduce the power consumption? Also on the optics side, there are quite some intelligent ways to save energy in the meantime. So the hot topic here is software-defined optics or adaptive modulation. So if you increase the speed, you consume more power. So if you don't need the speed, run at lower speed. Or simply use a few of the subcarriers only. You do the same thing in each and every modern automobile. So if you're driving an 8-cylinder, there's usually two modes. There's a performance mode where all the 8 cylinders are running, and there's an economy mode where the engine is only running on 4 cylinders. So saving energy by just using a couple of subcarriers there. Network design is also a very important topic here, because if you centralize your resources, then you can save power simply because of economy of scale. So backhauling the stuff as far as possible and concentrating, switching routing functionality can really help to reduce the power consumption of a network significantly. So we have done studies with major network operators, and the factor of what you can save there is rather high. Other topic, resource allocation. So in the old days, we didn't have a very dynamic optical network. It was very static. We had lots of one-by-one protection, so basically running 2 links in parallel, but only using one. There are much more intelligent and efficient ways now. You can do restoration in an optical system, so only switch on the capacity when you need it and not waste it. And last but not least, there's always the discussion about transport versus routing. So choosing the right transmission layer there is very important. And from all these items, you can see that you really need a holistic approach to reduce the power consumption and the carbon footprint significantly. You can't look at only one of these pieces. So this slide here I stole from Baliga in his study. So he tried to figure out how much energy is consumed in which part of the internet, and he made this study independent of the average access rate. And here you can clearly see that the WDM part consumes very little. So most of the power is consumed by the access, the metro network, and the core network, which by nature is a more packet-oriented network. So clearly, this is also an indication that, you should avoid switching and routing very far out in the network, backhaul it, and concentrate it. And since I got the indication that I have to stop here, my last slide. So fundamental strategies are clear. Switch where you can, route where you must. So don't use all the high energy consuming devices in each and every part of the network. Packet optical integration is a very important factor here, because this really allows you to have a more dynamic network, to have a more capable network where you can coordinate between the different layers of your network, or not let them run independently. And last but not least, virtualization of the resources, distribution of the load, so use the capacity where it is available instead of adding capacity in some parts of the network and having leftover capacity somewhere else is also an important point here. And this brings me to the end. Thanks.
Our next speaker is already coming on the stage, Manfred Wiegand from NSN. So Manfred.
Okay, thank you. Good afternoon all together. So I'm from Nokia Siemens Networks, and I'm also in the optical industry as the speaker before, Michael Ritter from ADVA. So I do not want to repeat all the messages that he has given, because I, of course, would say share them fully. So I'm of the same opinion as he is, that we need to find the right mix of optics and electronics. But as Nokia Siemens Networks, we are not just doing optics, we are also doing other business, and therefore our approach to energy is more holistic even than if we were just the optical company. So what you can see here is a new mobile site, which we reconfigured for green energy, so using solar energy and also wind energy, and battery as backup. And before the site was driven, for example, not for example, but before the site was driven just by diesel generator, and we developed here energy controller, which you can see in the middle, and which controls from which source the energy is taken off. And if there is an oversupply of green energy, the batteries are even fed and loaded. And all this can be remotely controlled via a network management system. Yeah, so as there are still a lot of these sites in the world, this is also one supportive element of saving energy. Now if we come to my business, which is more the optics, I think Michael has mentioned already that we really need to look on all layers, and we need not only to look on hardware but also on software. So if we look at the network layer, the most important things, of course, are to find an optimized technology mix of electronics and optics, which we call multi-layer optimization. And we do a lot of studies there together with operators, as ADVA is also doing. Sometimes we are doing it maybe also together. Then, of course, the optical network has to become more flexible. The technologies are there, and that's under development currently, and under implementation. So this is happening. Then a very important issue is that we need also to have energy-aware protocol design. Yeah, so there's a lot of activities going on in the industry to look at other protocols than just IP, to also save energy. So, and this of course is also true, as Chris mentioned in the beginning, to reduce the energy for the end devices. So, site consolidation is a very important topic, still especially in the access, because most of the energy is consumed in the access. Yeah, and of course, to find and get a feeling about the effects that this could have on the power consumption, you need to have intelligent planning tools to do a couple of what-if studies to see really the effect. Because what we see when we talk to operators, that they are planning and they know what they do, but they have no clue what it would mean when they would do it another way around. So this is the network layer, and I'm personally more active on this layer. Of course, on the equipment layer, you can do also a lot. You can, of course, use sleep mode. That is something which is also under development since a couple of years. So switching off unused hardware, for example. You can do adaptive link rates and all these things, which Michael has mentioned before. But you also need to find an optimized integration level here. So sometimes when we look at how energy is wasted basically in equipment, backplane capacities are wasted. So this is also, if you look in the longer run and for the evolution of a network, that is also not the best way of doing things. And finally, on the component level, it's very important also there to push from the industry the optoelectronic integration, I think, because we all think, or I hope at least that we all think, that optics is the only way, more optics is the only way to reduce power consumption and get the higher speeds, both. 1 minute. Yeah, so then I will conclude with this slide and not use the other 3 slides. So this is something on a longer term network vision. It's a simple network which I have drawn here, and I know that this will not be the only solution, but because there will never be only one solution, there are always different solutions. But this is quite interesting because what you see here is an access network which is completely passive and which goes up to 100 kilometers. It's based on what we call next generation optical access. It is an ultra-dense DWDM system with 1,000 wavelengths which are closely together in the C-band. And we are using optoelectronic integration and together with coherent detection, or coherent detection together with optoelectronic integration, to get this, to get the distance, to get the power budget, and to get the high wavelength selectivity. So this is something which has finally made it also into FSAN as a next generation PON system, which will be then standardized up to 2015, hopefully. So, and this then should be finally terminated in something which we call UTP. That's a unified transport platform where I think the data plane is simple and is available, but where there are some thoughts still about the control plane to reduce IP MPLS routers, at least the ones as they are available today in the core, as much as possible. And with this, I would like to close my talk.
Thank you, Manfred. Manfred, you can stay here as well and keep us all company. You know. There'll be more people up here than in the audience by the end of the time. So, on to the next speaker. I'd like to introduce Liang Liang from Huawei, a company that's quite new to our community. So I'll hand over to you, Li, and you can talk us about green in Huawei. Yeah? Thank you. Have some technical shenanigans going on here, I think. Takes a while for the lab projector to project. Yeah. Pictures. It's got to come all the way from China, huh? Sorry.
It's a long way from China. So.
It's physics, you know, you can't get away from it.
Yeah. Okay.
Fine,
Great.
thanks.
You have it here.
So, good afternoon. So, I'm very glad to be here to give a speech. In fact, this year is our second year for Huawei to sponsor the TERENA conference. So, that is why I organized my slides, so that I can tell you something maybe not many people, all the people know Huawei. So I will start with a very short introduction about Huawei, then tell what Huawei understanding about how industry can help the green in area, and of course some conclusions. So great. How is green? Even though the color in general is red, that means we are very innovative, enthusiastic, and we are looking for green solutions and offering solutions for our customer. So, Huawei is a pure ICT solution company. It has been in the world for more than 20 years now. So we serve something like 45 of the 50 top operators. This is our main achievement in the last 20 years. And we have roughly 146,000 employees. If you remember, for some of the people who were here last year, and we talk about 12 to 120,000. So we are still in a quite a reasonable expanding process. And we have our offices in more than 140 countries. And if you want to talk to Huawei representatives, you can also find them in Iceland. Good. And so we make roughly the revenue 32 billion. And also last year, I here reported that Huawei now has made a strategic step to divide the company into 3 business groups. That means carrier business group, enterprise business group, and the consumer business group. So after 1 year, I want to tell you that the Huawei enterprise business group made quite some reasonable success. Number one, so which we already find great partnership with the partners, with distributors, and also in the meantime, we consolidate our capacities providing solutions. And we have been able to make some very proud success in offering solutions and also in terms of our market values. And above all, I think we have received very good feedback from the market that really favor Huawei as a leading ICT provider for the industries, for enterprises. So basically, we offer the vertical enterprise ICT solutions, and from routers, switches to unified communication security, so also cloud computing and data center. Based on that, we offer our industry-specific solutions. So in this sense, for example, just mentioned smart grid or super grid to save energy. So this is what we are currently doing. So now come back to the real topic, green. Basically, the industry conclusion, as Michael or some other colleagues already mentioned, ICT itself produces only 2% of the total CO2 emission, only 2%. But with the proper, efficient deployment of ICT solutions in the world, in various walks of life, you can reduce more than 5 times of CO2 emission than 5 times of what the ICT itself produces. So basically, for us, Huawei as an ICT vendor, our mission in green, 2 parts. Provide green technologies to save energy and provide solutions to facilitate sustainability. That for us means total green solution. So basically, we have a total internal process to make sure that green products, green solutions will be developed in a green way. So this is the Huawei internal process, including supply chain, packing, and all the aspects. This is number 1. For example, here I'll just give one example, Green Campus Network. Basically, the technology saving is achieved from 3 different layers. Number 1 layer, that is from the chipset design. For example, this energy efficiency Ethernet, this EEE standards, we follow them. And also for the hibernation technologies, this is the component level. Then go to next level, that will be the rack level. The rack can be so designed with intelligent flow air to reduce ventilation resistance. Of course, also for the rack is so designed, every board can have a very conscious indication of power consumption. And above all, the density. 1 rack can hold more than 4 chassis, so that you really increase the power, reduce the power consumption per gigabit. And also, at the total network level, we offer the management system so that all the technology features can be embraced and made into reality. For example, the hibernation can be implemented from the network element to total network side. And so this management, not only for homogeneous network, everything from Huawei, but also for heterogeneous network compositions. So this is the Green Campus solution, network solution. So how about the education, so the solution for sustainability? We all know that we need a lot of ICT solutions. E-education is one. For the traditional e-education, you just need to connect classes, labs, and together with wide broadband. But in a new area, we need a new concept. So basically, we want to enhance the e-education beyond the campus and also beyond not only the students, but also the people, the constant education, people, unemployment people, and the people already in working, so people at home even. So this is number 1. Number 2, e-education is not just an enterprise solution. You need to leverage the established achievement from carriers like fixed broadband and mobile broadband. Also, you need to leverage the achievement from consumer markets. So iPad, smartphone, and also IPTV connected, or even set-top box at home. So with this, so the e-education we try to offer is an e-education everywhere and for everybody. Now, I conclude my presentation with just a peer. Huawei is ready to cooperate with ERAN, NRAN, with universities, research institutes to study innovative solutions to facilitate ICT solution deployment. Thank you.
And for our next presentation, it will be really interesting. I mean, it would be really easy for me to introduce this next speaker as Diego Lopez from Red Iris, but we have Diego Lopez from Telefonica. And you got the color wrong, mate. It's about green, this.
What green?
Green.
Yeah.
What's the title of your presentation?
It's blue, but with a shade of green.
So, Diego Lopez.
Thank you, John. Good morning, everybody. Well, the idea is precisely to show you how we have been addressing green technologies and the possibility of offering a greener world inside an operator like Telefonica. Basically, it's something that I would like to start with is remarking that everything around energy efficiency has become one of our key goals for the coming years. If you look at the diagram on the top right, becoming greener is part of our top commitments and goals for the coming years, and is at the same position of things like enhancing users' quality of experience and looking for additional revenue sources. So it's something that has become really, really part of our strategy for the coming years, and there is a formal commitment about to reducing by 1/3 our carbon footprint. We're becoming 30% more efficient from 2007 to 2015. There is, as part of this, we have taking it seriously, and there is an organization, we have organized multidisciplinary team that is spawning the whole Telefonica group and all the local operators and all the horizontal and vertical business units and the horizontal support teams, and giving a lot of attention to, in general, making aware our engineers, our commercial people everywhere, everyone, that this is important, and we are really taking seriously the coordination. We have forum in which we are discussing about this, and there is an event that is organized yearly precisely about discussing and promoting and rewarding achievements in energy efficiency. And for sure, we have built benchmarking, internal documentation, tools, and in some cases, even some of them we have been offering to some of our customers worldwide. The first thing, well, there is a strange projection here, but anyway. We have twice some of the countries. That's not true. The idea is that the first thing we have done is precisely about measurement. I think this is because I made it using a Mac, and this is, well, probably. Anyway, the idea is that we have started by measuring our power consumption, evaluating where geographically and where in terms of our business the highest energy consumption come. There is a approximate distribution by geographical area. You know, we are in several countries in Europe and in most Latin America. 80%, as you could expect, 80% is related to network operations, including data centers, and we're talking about 5 terawatt-hours per year. And well, precisely we are focusing there, apart from, of course, focusing in some other issues related to the rest of the 50% of our energy consumption related to, well, offices, call centers, and, well, even physical transport, for sure. We have established a plan for achieving this 1/3 reduction. And we have basically identified 7 different aspects that can be applied for improvement. mostly concentrated on aspects related to network operation and data center operation. For sure, apart from that, there are initiatives around about reducing air conditioning consumption, heating consumption, reducing traveling, etc. But what we have been concentrating on the aspect related to our networks, these 7 ones, you can, for example, highlight this selective switch off. This is one of the things that, for example, we are offering remote power management for data centers, and it is something that we are offering to our customers as well. And for sure, well, trying to team up both internally, in terms to organize what is a global telco operator with national different national sensitivities, legislations, even goals, trying to achieve it both at as a national level, as a regional level, as a global level, and of course talking with our providers, not only asking them to reduce prices and to provide more for less, but at least to consume less energy. And we have been teaming up with them and with the rest of the industry, participating in several projects and getting sales like the GSMA mobile energy efficiency. As part of this, if you are interested, that URL points to a much more detailed link with a much more detailed presentation on how we are achieving this. And well, since I'm working for the research part of Telefónica, I tend to move in the direction of what we are trying to achieve in the further on, beyond what we are right now doing inside operations. And well, we are trying to go a little bit far ahead, going to for sure, taking care of general eco-efficiency. That includes, in some countries, we are doing green generation as well. Having programs that we call Green by ICT, basically is very much connected to smart cities. We are heavily investing in R&D on smart cities, but as well in some other aspects. Like, for example, we are starting to apply artificial intelligence or computational intelligence methods to reduce the movements of people that have to go to the customers' premises to make repairs or so. The estimate that we have made in some of our Latin American operations has been that we have been able to reduce by more than 35% the amount of fuel that was consumed in doing this, in avoiding these displacements. We have we are starting to work as well in energy-aware network, identifying drain points, identifying patterns of traffic that are more energy consuming, and trying to identify them and to plan ahead of them. And something that is very much, and we are trying to move ahead on, is precisely heterogeneous networks, the idea of taking advantage of all the network fabric that is available for a certain connection to avoid the excess of capacity or the excess of power, mostly in mobile environments. Well, we are trying to build awareness, share experience. We have participated in a network of excellence, precisely on energy awareness, and there is a commitment of all the projects that we start on network infrastructure in the R&D departments to make an energy efficiency statement and contribute to these networks of excellence. As an example, we are participating in a project that was presented during a workshop on Sunday, Manticore, and we are collaborating inside these projects with the Green Star initiative from Canada. Well, just to finish and align with the question at the beginning, how can we help, etc. was, what we propose you is this. Let's sit, let's talk about how you can use our network and our data centers. For sure, this is why we are not only green, we are interested in making some money out of being green. Well, but let's talk even about the possibility of engaging in this kind of green by ICT. Let's go smart in the cities. Let's go on talking about integrated head nets, something that is of very extremely high interest for us. Well, let's talk about whatever weird, crazy idea you have about to going and becoming more efficient, because for sure would be interesting to us. That's all. This is good.
Okay, a slight change to the order. We just switched the last two speakers, so I'd like to introduce from level 3, Remco Freeling. I was going to say a fellow Dutchman, but that's not quite true, is it? Come on, let's hear about your greenness.
Thank you, and good afternoon, everybody. So, I have a high risk of sounding repetitive compared to the other speakers. So, yeah, I think maybe it's good to come out with a daring statement and saying that level 3 is not green yet. So we're on a path. Like yesterday, the CEO of CCP Games said it's more about the journey than the end destination. But I think speaking about this subject, it's really an really important subject, and that's why it's also very important for level 3. We're at the start of that journey a bit, but we did a very bold step to begin with. I don't know, not many people know that, but level 3 used to own a coal mine, and as a first step, we sold that last year. So that's good. That's out of the equation now. So, but it's important to look at this subject, because yeah, of course, we are also becoming more and more energy efficient, and we work on energy transition. We have a lot of data centers in our network. We have a lot of inline facilities where we all yeah, consume energy. And more we're looking at trying to get power suppliers to supply us with renewable energy, and with that reduce the carbon usage in our operation. So we have all kinds of policy statements. We're going to comply to the European Code of Data Centers, the Code of Conduct of Behavior. And yeah, I think what's an important slide, and that's why I put it in here. If you look at our industry, we have the telecom providers, and you have our customers. But you can easily also switch telecom providers for hardware vendors, and then the customers are the telecom providers, where I think the industry will go through a couple of phases, looking at the strategy going from a more corporate social responsibility approach to having really senior ranking officers responsible for sustainability. So in your senior executive suite, you will have people that are responsible for making sure that your company is going to become a sustainable, responsible company. And then yeah, you will have the same from the customer side. So what we see, and that's, I think, a very big motive for telecom operators to become more and more sustainable, is that, for instance, especially in Europe, you see that probably more than in other areas of the world, that big multinational companies and the public sector are putting this as a qualifier into their RFPs and RFIs. So you have to show to your customers that you are doing all you can do to become more sustainable in your operation. And then the ultimate part, and that's because in telcos, of course, we sell telepresence solutions, all kinds of other solutions that will basically, that people don't have to travel anymore. You will see probably a development in the value proposition in those products, where the telco has to explain, if you use this, solution, that will mean that you will do much more better, and that's then also going to be qualified proof that you do it much better. So if you sell the product, your customer will do much better in their sustainability reporting. So yeah, if you look at the level 3 network, currently we don't have the full view of that yet, the energy consumption of the network. What we do is we, for all our data centers, we track the PUE ratio, so the power utility effectiveness ratios, and we do all we can to lower those as much as possible by applying a new technology, free cooling, cold aisle attainment, and all that kind of solutions. For instance, I had a look at how many buildings we utilize in Europe to run the full network, and that's more than 1,000 buildings, which all have to buy basically green power to become fully green. We're getting there. So, for instance, in Germany, we're already fully green, and we have a certificate that I can show on the next slide. And the same is true for the UK and Belgium, and in all the other countries we are trying to buy more and more renewable energy power. So as I said, we're on a path. So if you look at that's another one for Europe. Our total power bill, so what we pay to the power utilities, is about, it's more than 50 million euros on a yearly basis. So it's quite significant. So if you can reduce that, it's also a very important cost reduction in our own operations. So, and then, because my question was, how can we help each other? I know that the JL green teams are very busy on creating all kinds of ways of how to report on your basically greenhouse emissions in your network. So it's totally already prepared way of calculating and reporting in a telco network. So I think we could learn a lot from that and possibly also use that in our own operations. And yeah, do we have customers or a chief sustainable officers yet? No, we don't have one, but I think we will have one soon in level 3. So to close, this is, for instance, one of the reports that we use to track the PUE measurements. It's in weeks, so they're all different measurements, and then you can see the average, which is the red line. And this is one of the renewable energy certificates from Germany. And then my last slide, oh no, it's two other ones. Also, our employees are getting more and more green. So we have more and more people driving electrical vehicles nowadays. And this one, as an example, that I came across in one of Bill Centerno's newsletters. This could be a new inline hut in our network. So it's a repeater station in our fiber networks. This is a micro data center which is fully solar powered, and already showed this to our architecture and engineering guys. And that they really like the idea. So there's also a lot of good ideas coming out of the research community that we could use in telecommunications also. And that's my answer. Thank you.
And now I'd like to welcome our last speaker in this session. So prepare your questions, because after Rodney Wilson from Siena, it'll be time to ask some difficult questions, okay? That's your turn. So, Rodney.
So, good afternoon. I'm Rodney Wilson from Sienna Research Labs in Ottawa, Canada. And I knew that I was on a panel with a number of my esteemed colleagues who are also manufacturers of fine telecommunications and optical equipment. So I wanted to come up with some analogies between what perhaps you're doing at home with what you're doing within your networks and what we're doing at Sienna. And really it's all about wasting power and how to avoid the problems associated with inefficiencies in both network design and system design. So I have some interesting analogies for you. So how many of you have replaced incandescent bulbs with compact fluorescent or LED lighting at home? So I went to the local Home Depot store and took some pictures. And here we have a picture of LED lighting. So how many of you out there have done this? Environmentally responsible people everywhere? Very good. Well, this is what we're doing in Sienna with our component design. So we're looking at advances in component engineering so we can design with the lowest possible power footprint in our technology, and at the same time reduce the thermal requirements. This is also reflected in how we source our products and how we actually design to meet these requirements. So it really reflects on our entire supply chain. How many of you have motion detector light switches at home that turn off the light if you're in the room or maybe if you fall asleep? Anybody done that? I know a lot of the hotel rooms feature this. The corridor in my hotel room here in Reykjavik has some of these sensors that actually have the ability to dim the lights or turn them off. And of course, this is what we're doing with our systems to actually reduce the amount of power that's consumed in idle channels. So if we have a system, it's able to idle a channel, reduce the power consumption, and actually improve the performance. My third example is kind of interesting. Now, I live in Ottawa, Canada, and the temperature range is plus or minus 30. So there are lots of places that are colder, and there are lots of places that are warmer. There are not too many places that have a 60-degree spread over the 12 months of the year. So that means that if you, in the summer you have air conditioning and you want to cool your house, and in the winter you have a furnace in the basement and you want to heat your house, and systems switch back and forth. And everyone has a thermostat to adjust this. But 2 years ago, the Ontario government came out with a fabulous new program. And they would replace your thermostat at home with this state-of-the-art Wi-Fi enabled remote control thermostat. Now this was fantastic because it offered you some monitoring capabilities, right? So you could monitor the temperature at home. And you could actually remotely change your temperature. So not only just time of day cycling, but also remote control. So this is a fantastic thermostat, and it was free. So they'd come in and replace your thermostat, no charge to you. The trade-off, though, was that when the power grid reached maximum performance, they could remotely change the temperature at home a few degrees to save power. So that meant in the summer when it was really, really hot and everyone had their air conditioner on, the power authorities could go in and kind of change your thermostat by about 2 degrees, make it a little bit warmer. And in the summer, or in the winter, the reverse was true. When it was a really blistering cold day and everyone had their furnace on, maximum burn, they could actually go in and make it a little bit cooler. So it's a great program. But the analogy, of course, is here to what we are doing with cloud computing and shared resources. So in our network architectures and designs, we're very interested in creating an environment that allows us to pool our resources, to virtualize our requirements, to put them into common data centers, and reduce overall power consumption through this kind of sharing. And the analogy kind of works, because the same thing is true. We want remote monitoring capabilities. We want to know how our system is working from a remote location. We'll want to be able to change some parameters on the fly, but at the same time take advantage of the shared community of cloud architectures and shared data centers. So, we're moving towards this virtualized environment, and so in a simple way, it's an excellent analogy to the high-performance thermostats we now find at home. And for my last slide, to really bring it back to a technology check that brings a point home, is according to ISO measurement techniques and what is now coming out under the heading of, if you can't measure it, you can't control it, and if you can't control it, you can't improve it. There are a lot of research results looking at comparative network technologies, and they're expressed here in tons of coal in both capital expense as well as operational expense. And as one of the previous speakers pointed out, you really want to be able to operate at the lowest possible consuming architecture. In this case, comparing things like the optical switching consuming, over a 5-year span, maybe 5 tons of coal, compared to other more power-consuming techniques. And of course, when you look at the operational expense, you also see the travel to install and repair, as one of the other speakers mentioned out, as perhaps the guiltiest party. So virtualized networks can save as much as 50% of your carbon emissions using low-cost network architectures that actually reduce the carbon footprint are also very key. So thank you very much for your time. Those are my slides. And I'd like to thank Kees de Laat for his green laser pointer.
Okay, it's time for some conclusions, and it's time for some discussion. So first of all, can we thank the panel again for their full and frank expose of their green parts? So thanks. Is it possible to turn the lights up a little bit in the auditorium? Can we turn the lights? Yeah, you get the green light from me. Thanks. Do we have any questions from the floor? Kees de Laat, I can see. Somebody will come to you with a. Okay, we'll take Victor Rice first, and then you can give the microphone to Kees. Okay.
Okay. I think, yeah, you talked about the energy reduction that your equipment can do, and I think that's within your responsibilities as a provider. So that's good, and so that's 2% of the world consumption, and you can reduce it with 30%. But you also have that other aspect. I think somebody alluded to it, that you can reduce, of course, the travel and so on. That's not in your responsibility as a network manufacturer. But I think it's essential that will work. So the indirect savings are very important. So how do you think you can control that? How do you can stimulate that? And how can you measure that? Although somebody else will measure that, of course, because they see it as their savings and not as your savings. So what's the indirect and the direct measures?
Rodney, you're going to take that? Or are you just moving the microphone around innocently?
Okay. From our perspective, I certainly think that the travel aspects are part of our responsibility. It's a shared responsibility, and our customers evaluate the applicability of our solution based not just on the capital expense, but the operational expense. And truck rolls and moving technicians around, and the cost of operating the networks is very much a criteria against which we're evaluated.
So the answer to your question then is what remote telemetrics and control mechanisms are built into the equipment to reduce the number of truck rolls. And there are considerable features in all our technologies that allow you to do that. And it depends on the exact nature of your deployment, whether or not which features apply in your environment. But certainly the ability to remotely configure and provision equipment, to commission and decommission slots or unused slots is very much a part of certainly Ciena solutions.
You okay with that?
I see that as direct cost. Yeah, that's your equipment.
But isn't, maybe I should interrupt. Maybe this is an issue that the end users need to do an audit and interested. I mean, how many institutions here do a greenhouse gas carbon dioxide audit annually? Well, no, at all. 1, 2. Can't see them.
Another one over there.
It seems to be about 3, which is not a great number. So it seems to me that that's where you need to start. Anyway, Kees de Laat, you had a question.
Well, a few remarks. One is, this is about how can the industry help us to be green. So a few things where you could help us. One is, I would love to see way more proportionality. So if there is no traffic flowing, no energy usage. So get more linearity, that if more bandwidth is used, that Ethernet cards use more power and less power if there is less traffic going on. Currently it is so you turn on the equipment and then poof, it is at a certain level and it stays there, There's no proportionality at all to data what is flowing through. We are currently working with Huawei. They have a switch which on one Ethernet kind of board can do that, but I would love to see this way more. So can you raise your hand, vendors, who is working on that? Data, so energy proportionality, because that's what we need to see. The other thing is, if I look on my laptop, my beloved Apple laptop, I can read out the power of many different components. It shows me the power usage, the actual power usage of the GPU, of the CPU, of this bridge and of that disk and so on. So very detailed. Currently, these kind of readouts I hardly see in any other equipment. So I would love if the industry builds in ways that we can monitor not just the entire apparatus. We can do that by just measuring the power going into the fat copper power cable going into the switches and routers, but I would love to see more component-wise readout. And if you don't believe me what can be done, I can show it in the laptop in the break, so approach me. And the third thing is I would love to see this kind of monitoring put out in information systems on the web, such that when we are scheduling tasks, that we can actually do a kind of optimized scheduling of cyber resources across the globe. So you guys are all familiar with perf sonar, which shows us how many octets are going through a port at any time of day and so on. I would love to see this also for the energy usage as function of the flows which are going through it. Because if we have the information available, we can program it. Then the software-defined networks can take that in their algorithms to optimize this. So that are my questions or requests or whatever you do with it. Thanks.
Do I see any other questions?
Yeah. No. Yeah. No.
Okay. We have an answer.
When it comes to those requests, I'd love to see them as well. I mean, it's, we are operating a network, and we'd love to see it. To some extent, what I can say is that in our case, we are doing that. Or there is a group in Telefonica R&D that is working at least for the trying to optimize, at least in the case of the mobile antennas, to try to, well, as you say, to make not individual equipment by individual equipment, but to try to make a certain region, the cells in a certain region, to have an energy consumption that is linear with respect to the utilization. This is something that we are so, well, we are, I'd say we're heading in the same direction. Yeah.
So Case is saying he'd like to see a green sonar. Sounds like a great idea to me. Any more from the panel? Okay, I've got two questions. The gentleman up there with the microphone, and then we'll come to you. So, okay, one more on the panel first.
Cisco is participating in an FP7 project where we are, it's a building energy management, and we take the energy from the sensors throughout a network, tie it back in. You can control the lights and everything from the IP phone, and bring all that information back to a leaderboard in the lobby so that you can see this room is, no one's in it, so there's zero energy consumption in it. This room has a lot of people, so there's a lot of energy consumption. Hopefully, as we make people more aware of how much energy they're using individually within rooms, they'll start to respond to it and help clean up their own act.
Well, also one comment from Huawei. So for this energy saving, especially this hibernation concept, I think it's still a long process. And currently, so people start from a chipset design, but not all the chipsets are really newly designed to support this kind of feature. But so that is the chipset level. But then when all these features are available for all the relevant or most important components, then people can, based on the analysis, make really the right decision, whether the network element level or up to the total network. So it's a deep sleep, this hibernation-based deep sleep. I think it's based on the very complicated calculation here. This is number one. And then number two, this is also for the real scenario relevant. But because you need to resume the things, for some of the scenarios, you have to resume it very fast. Then this resume it plays also a restriction there for the optimized usage of this power saving concept. But anyway, I mean, this is a process, and I think we are all on the way to improve it.
Okay, thank you. Question from near the steps. Yeah.
Yes. There's one topic you haven't mentioned, any of you, I believe. All your improvements in energy functionality in your equipment will obviously mean that the equipment will have to be replaced. So my question is, what about the waste? All the legacy equipment which is not performing any optimally any longer with respect to energy consumption. What do you do with that? Do you have any, especially the equipment vendors and equipment, you guys who produce the equipment, do you have an attitude or to the waste produced by equipment replacement?
Sienna has a fairly aggressive program on recycling technologies. The other characteristic is that a lot of the equipment is very long served. The equipment that's installed in central offices and so on obviously sometimes have 15 or more year lifespan, and so part of what we're able to do is future-proof the technology and not have to do a complete truck roll replacement, but replace certain key components.
May I add that there are also a lot of national and, of course, company internal policies available for taking back equipment, and everything must be recyclable and so on. Yeah, I'm not an expert on this, but definitely there are these policies in place, I would say, normally, at least in all European countries. There are strong regulations.
Panel members want to respond to that? Okay, we're going to the next question from the front row.
Albert Hankel from Surfnet Dutch. I had two questions, but both of them were more or less already put forward. But I want to underline that if we want to do to calculate our energy footprint, then we need to know the energy usage of our network equipment, and it's very hard to read out because we need to use clamps and use external measures. So I would love to see equipment which can read out its own energy and in a transparent way, so we can get it out of there and make our own report on this. So if that's really an area where you can help us being more efficient, at least, because as you know, only by measuring you know where to get the most gains. And secondly, my second question was also how many of you can say that equipment and packaging is made in a sustainable way? Because if you look at servers, then I heard numbers of like they should only be used like 1 or 2 years before they are from a total cost of ownership perspective not viable anymore. You should replace them. So maybe you could also think it from a different way and say, okay, our servers need only to be productive for 2 years, and then we should be able to recycle them or make them degradable in a good way. So, if you have any comments on that, I'd love to hear them. And if you want to talk more about these topics, then please stop by.
I did a lot of research when I prepared my talk here, and unfortunately I found more than I could read during the time. So there is really a lot going on in research, but also in development on energy consumption, and also how energy is being measured. And as you may know, there is also standardization development ongoing, how energy consumption is really measured, because of course it has to be standardized if you want to compare it. And of course these things will go, all these things will go into the equipment. Of course it has to, because when the standards are there, of course all our customers, they will ask for it. They are asking today already for it, more and more. So this will happen. So with respect to sustainability, there are also long policies available in the companies. So at least for our company, I could with good confidence say yes, that is sustainable. So there are also European regulations since, I don't know, 10 years or so in place. I still remember 10 years ago, don't know, when we had really to go through all of our equipment and get rid of all material which is not, how would you say, which is poisonous and so on. Yeah, so these regulations are in place and they have been followed strictly.
Yeah, exactly. I think the regulations are in place since quite some time. And if you want to get ISO certified, TL 9000 certified, and so on, you have to follow those. But as you say, it's just a start. It helped us a lot, I believe, over the last years. So we all got better in that. But there are also different ways to go, like we do some pre-assembly or whatever to avoid packages, some staging and so on, where you just put it out of the box and most of the plug-in units are already in there. So there are different ways of increasing the efficiency there. But I think there's still some room to improve there. And I think on the waste thing, it's the same here. So each customer contract we sign with our customers, it has a clause in there that we basically have to take care of that. So I think that's a very good move here in Europe. I think it's the same in the US as well. And it helps us to move, so there's some pressure behind. But as you say, there's much more which can be done.
Yeah. In fact, what has surprised me is that up till now we've only been talking about defensive measures. How can we conserve? How can we measure on a micro level? But if conservation is not enough, I think we have to look at the other side of the coin, which is the production side. I think the most beautiful thing about Iceland is more than 90% of their energy is renewable energy. So I would urge, first of all, thanks to all these 100 gig megabit, 100 gig links we'll have to Europe, for example, is that all TERENA members put their data centers in Iceland, for example. They could come to Canada, but then you have round-trip delays and things like that. So I think as a community we should also look at the famous follow the sun, follow the wind concept, which Bill Saturno had put forward in Canada. And I think in the coming years we should spend more time on these aspects. And the famous inline hut of Bill Saturno, some say he's totally crazy, but one has to be crazy to innovate. When you're talking to Daniel Nocera, making energy out of water. By the way, I found it. It's artificial cobalt and phosphate-coated silicon leaves you put in water. So he claims that with 1.5 bottle of water, you can power a small house. And with 1 swimming pool of water, you can power a small plant. Now, when you think in developing countries where there is no power, I think that would be great. I would even have a bottle or 2 of that water at home. So I think this is the future, not conservation per se. Conservation, we have to conserve, of course, but we have to look at the production side of energy.
Can I ask the panel, how long do you think it will be before you have implemented energy monitoring at the module level so that people like Kees can calculate and switch things off? And are we talking about 5 years, 10 years, 3 weeks, you know? I mean, is it going to be available by Christmas?
Good question. Currently what we are doing is, and we discussed it just, what we are doing is monitoring, of course, data rates, yeah? So, and of course, it may assume the linearity, which is not there, yeah? So we may shift away from looking at the data always and look at the energy consumption. This may take a while, but with the standards which I mentioned before also, it may happen, yeah.
There's another question from Kees Talat.
In the meantime...
Kees Talat looks like he's drowning, but I think he wants the microphone.
John, if you allow me, sorry. It was in the meantime just to note a couple of things. One is precisely, we were commenting as well that the idea of having the energy consumptions as an additional input to a controller in a SDN environment would be really lovely to have. Yeah. And second, regarding what Dave was mentioning about new ways of generating energy, the important thing there is that in general, those new ways of generating energy are based on tiny generators. They are not based on big plants. And there, the communication between the different pieces, well, what is normally called a smart grid, but it's going, I'd say it's going a little bit beyond. It's a smarter grid, would be definitely necessary. So we have to keep the balance between the energy you are consuming to keep the smart grid running and the amount of energy you produce that way. So
yeah, I see some articles on using LTE to manage power grids and things like that. So this is...
It's the kind of interesting challenge.
You know, I think one of the realities is that we design installations and configurations to meet very stringent power budgets and have done for a very long time, but it's a manual process. And so what we hear suggested here is what can you do to make that a more automatic process? And then if we extend to the future, then what can we do to make routing decisions or topological decisions automatically based on most green routing as opposed to shortest path or fastest throughput. So there's a continuum of research here So the answer to your question is, if you bought a system today, we would help optimize the power budget. We could tell you exactly what the draws were for each card, each shelf, each cabinet, and for the whole network. But like much of what we do in the R&E space, it's a manual process. And so, so a lot of work has to be done to make that a more automatic readout, a more automatic dashboard. And then the next step beyond that is to actually adapt it for more dynamic network architecture and configuration system. And those are pretty exciting suggestions.
Yeah. Case.
So I typically point out at end of presentations I nowadays give that TomTom has implemented that in their route planners. Yeah, I can say navigate to work, and then it asks, do you want a bicycle route or the fastest route, or do you want an eco route? So I can do it in my car every morning, but I cannot yet do it in the cyber infrastructure. So about 2.5 years ago, I came up with this term, well, why don't we build a green sonar? Because perf sonar is now a success. And actually, ESNet took up that challenge, and in the ANI program, they actually at least already implemented the readout of every device in ESNet. And yesterday morning, they actually did put it online. So if you go to my.es.net, you will find there somewhere a link which leads you then to the power readout of every component, and they show then the averages and so on. So that is a first step which I would love everybody to take.
Okay, Victor's got one question, and I think I'm going to have to make this the last question because I'm over my power budget and I need some refreshments. Okay.
It's perhaps a remark. I think I fully agree. We need to have these parameters, and like in Manticore and in Green Star Network project, we are utilizing these green parameters of the equipment, of the switches, of the routers, of the links, and the higher layer services. And based on that, we make an IP network, or we move the services from another place to another place, depending on where the energy is right. So I think we are getting that information, and I think we have to keep on trying to optimize it. So we are working on that kind of things, and it's working. And again, it's based on the ideas of Bill Santino. You need weird people to stimulate the thinking, I think.
Okay, with that, I can't see any more desperate waving hands, and I think I'm really hungry now. So thanks to the panel, and thanks to everybody for coming. I've really enjoyed this, and some good ideas. So thanks everybody. Enjoy the rest of the conference. Thanks.